Alright, here we're going to be taking a look at Chem 351 Quiz 1 from 2016, the key. So the first one is rank the dipole moment from smallest to largest. The key here is to recognize electronegativity. So you have nitrogen, fluorine, and oxygen, and then H. So find those polar covalent bonds. Fluorine, oxygen, and nitrogen all in the same row of the periodic table. Fluorine is most electronegative farthest to the right, so it had the most polar covalent bonds, so it had the largest dipole moment. And oxygen follows next, the nitrogen, and then of course CH bonds are not polar. For the second one, about drawing those dot structure, this is a difficult one. Show your work include all lone pairs, indicate formal charges for all atoms. Hint, atoms all obey the octet rule. No formal charge, but we could still have charges. This is a net neutral charge. Had 26 lone pairs, 26 pairs of electrons. So first thing, I put the sulfur in the middle, the oxygen's all off it. Then I would add the H's to those oxygens. So these are kind of self-explanatory. And then from here, as you fill in the electrons, you notice because sulfur is lower in the periodic table, it can have an expanded octet. So it still obeys the octet rule, but it has a formal plus charge where the oxygen has a negative charge. Very difficult one. So the next one, kind of a way to think about why does electronegativity decrease as you go from right to left across the periodic table. So going right to left, so things like fluorine back to oxygen, nitrogen, and carbon. So it decreases because size increases. I mean, the valence electrons fill the pull of the protons of the nucleus less. Right? Bigger atom, the nucleus is filled less. Also, the elements on the left are not as close to having a stabilizing full octet, right? So not having a full octet, the octet rule again. So in the hybridization state, thing looking for here, how many pi bonds does that element at carbon have? In this case, this carbon has no pi bonds, so that'd be sp3. This carbon has one pi bond. There's a CH here, of course, so it's sp2. Similarly here, this carbon has one pi bond and 3 sigma bonds. There's an H that's not drawn in, so that would be sp2. Need to draw the hybrid orbitals for number 5 of an sp hybridized carbon. Sp means it has 2 pi bonds, so it'd have 2 p orbitals, one for each pi bond. And what's left are these sp orbitals, 50% s, 50% p, and they're a little squattier and fattier, and they make they're a little bit generally close to the nucleus, and those are what make the sigma bonds from that alkane, a triple bond. Alkyne, excuse me. Okay, for the number 6 here, it says define the acids and bases on each side of the reaction below. Of course, remember, acids are electron deficient, bases are electron rich. So if I see a negative charge, I know that must be the base, particularly that nitrogen, that lone pair. I see, so if there's going to be a reaction, the other thing must be an acid. There's also a polar bond to hydrogen to this oxygen, so that's an acid. On the other side of the coin, again, I'm looking for charges. Here's a negative charge, so that must be the base. Bases are electron rich. Acids are electron deficient, so again, that polar NH bond. That's how you'd find those. Draw all the lone pairs and all the molecules above. That's self-explanatory. Nitrogen, if it has a negative charge, it must have 2 lone pairs. Oxygens all have 2 lone pairs, and they have 2 bonds. Nitrogen has 1 lone pair and has 3 bonds. Oxygen with a negative charge would have, with 1 bond, would have 3 lone pairs, and then 2 bonds, 2 lone pairs. Correct curved arrow star materials. You start at electron density. The lone pair is lassoed there. It goes after that H, which is delta plus because of that polar bond to oxygen. And then make sure you zoom in here. You really want to show the 2 electrons in that bond leaving and going to that oxygen. Which, of course, you can all see the new NH bond that's formed. New NH bond is formed there. As well as where that lone pair that was that OH bond ends up as well. Here, drawing in some formal charges on the charged atoms molecules below. Carbon with a lone pair and 3 bonds, it would be a negative charge. It's carbanion. Nitrogen with 4 bonds and no lone pairs is a plus charge. Oxygen with 3 bonds and a lone pair is full octet, but has a plus charge. And the sulfur here with 1 bond and 3 lone pairs is a negative charge. Finally, here for the bonus, the 2 sentences just explain electrons' wave-like properties and explain how it's represented in a bond. Pictures are helpful. Orbitals represent electrons as waves with phases. When similar waves or waves interact, constructively a bondus form and an antibondus form when the orbitals interact destructively. So think about 2 waves coming together. If they're in phase, the waves get bigger. It's constructive, and that's when they show these shadows form. If they are out of phase, they destructive. That's why we have the opposite. They do not match up there for those electrons as waves.